10.7. So here's the first question that we have here. It says that a school nurse, do you guys want me to zoom in to this a little bit? Like the words get a little bit bigger. I'll just have it zoomed in a little bit. Says a school nurse is assembling first aid kits for each classroom at his school. The following table represents the proportional relationships between class size and the number of bandages needed. So it looks like if I have 20 students, I need 40 Band-Aids. If I have 25 students, I need 50 Band-Aids. If I have 30 students, I need 60 Band-Aids. So when we look at this, remember that the main point of this unit is unit rates. Okay, so remember when we're finding a unit rate from a table, the first column is always your X, second column is always your Y. Okay, so I'm just going to pick a few of these. I'm going to skip the 27. So when I'm going from 20 to 40, what am I multiplying 20 by to get 40 here? Multiplying it by 2, right? What about the 25? What do I multiply 25 by to get 50? By 2, right? So I'm multiplying all of my X values by 2 to get to my Y, which means that my unit rate for this problem, so my unit rate is going to be 2. Okay, so for every 1 student, I need 2 bandages. Then, part A says, how many bandages is the nurse giving per student? So 2, she's giving 2 bandages per student. So this is correct. And then for part B wants the equation. So remember your equation, we're still using y equals kx. And k is our unit rate. So your unit rate is always going to be your k. So I'm going to have y equals 2 times x. And which one of these equations most resembles this equation here? Our variables are a little bit different, but the order of the numbers should match. So which one of those equations has the same order as y equals 2 times x? B equals 2 times s, exactly, yes. So this would be the equation that we want to pick for checkpoint 7. So close, yeah, very close. Natalie or Dawson, do either of you have questions on this problem? Okay, let's go on to the second one. All right, this one, Dawson got correct, but I'm going to go through and explain it. It says that a new author wants to increase book sales for her new novel. She does interviews to promote her book sales for the number of interviews, and they're recorded below. So it looks like for 4 interviews per week, she sells 1,500 books. For 8 interviews per week, she sells 3,000 books. So again, we want to know which statement describes the ordered pair 12, 4,500. So I'm going to draw a table here that looks exactly like it, but is slightly different. So this is interviews. And then this is book sales. And we are looking at the point 12 and 4,500. So we're looking at this pair right here. Okay. And so if I look at the point 12, okay, 12 is talking about what? What is this 12 describing? Is 12 talking about how many books I'm selling or how many interviews that I'm doing? The interviews, right? Because this 12 is right next to interviews. It's in the same row. So 12 is talking about the number of interviews. So when we have this point 12 comma 4,500, the 12 is talking about 12 interviews. And so when she does those 12 interviews, how many books does she sell? 4,500, right? So if she does 12 interviews, she will sell 4,500 books. So if I look at these answer choices, this first one says the author gave 12 more interviews and 4,500 more books were sold that week than the week before. This does not make sense because I have no baseline. Like I have no, the first week she did this many interviews and sold this many books. So because of the wording of this, it doesn't make sense. The second one says that the author gave 12 interviews that week and 4,500 more books were sold than the week before. Again, I don't know how many books were sold the week before, so this one also doesn't work. The third one says the author gave 12 interviews and 4,500 times as many books were sold that week. The wording of this one, 4,500 times as many, I still don't know how many books were sold before she did these 12 interviews, so this one also can't be right. So it looks like this bottom one here, the author gave 12 interviews and 4,500 books were sold that week. This is the one that we want to pick. So it's the most literal from the table, right? She gave 12 interviews and sold 4,500 books. That's what our table's telling us. All right. Questions, or are we good to move on? Ready. Next one. The picture ones. Okay, so an ecologist wants to measure the population of mule deer in the Rocky Mountains. Examine the following diagram, which shows the number of mule deer in a specific range of the Rocky Mountains. Okay, so when you have the diagrams, I don't know if you guys remember, but we did some diagram stuff last semester in Unit 2 as well. You want to use a pair that you're given. So here it looks like we have 1, 2, 3, 4, 5, 6, 7 deers. We had in a total of 2.5 square miles. We don't know how many for 25.5 square miles. Part A says, assuming the mule deer population is proportional, how many mule deer can the ecologist expect to inhabit the 25.5 square mile area? So we're going to set up a proportion here because it says that the relationship is proportional. And a proportion is two fractions that are equal to each other. Oh, that was weird. Okay. And when you're writing your proportion, remember you need to have the same units on top and the same units on bottom. So with this diagram here, each one of these dots represents a number of deer. So how many dots are in this first picture, this first square? So there's 7 deer. 7 deer in my first diagram, and they cover 2.5 square miles. What is happening? Why is it doing that now? Weird. There we go. Oh no. I can do this. I believe in myself. All right, I did it. Okay. So for every 7 deer, right, it covers 2.5 square miles. Now, do I know how many deer cover 25.5 square miles? Do I know how many that is right now? No. So since I don't know how many that is, what can I put there if I don't know what it is? not a 0. I could put a variable, right? X. I don't know how many deer there are, so I want to represent it with a variable X, because I know X has to be some number. I just don't know what that number is yet. And then on the bottom, it covers 25 1/2 square mile. I don't know what is happening. Like, why is it doing this? Yeah. Right. Hopefully that doesn't happen anymore. Okay. So this is where this problem gets a little bit tricky. And we have a few different options that we can do to solve this. The first one that I think is probably most beneficial to prepare you guys for 8th grade is to do something that's called cross multiplication. Have any of you guys heard of that before? Cross multiplication? Perfect. Awesome. So for cross multiplication, you multiply diagonally, right? So I'm going to do this 25.5 times 7. I don't know why it's doing this. It's never done this before. So I'm going to pull up in Desmos really quick. We got some fractions. So I'm going to do 7 times 25.5. I'm going to just make it a decimal. So 25.5, I'm putting 25.5. When I multiply those two, I get 178.5. And then my equal sign is going to stay in the center. So when you're cross multiplying, you multiply diagonally and you have an equal sign in between the two numbers. The next thing we're going to do is multiply x times 2.5. So what would x times 2.5 look like when I write that out? Remember, I'm multiplying diagonally, so I'm doing this x times 2.5. So how would I write that as multiplication next to each other? What would it look like? X times 2.5. Yes. Remember that whenever you have a number next to a variable like this, 2.5x, this represents multiplication. So 2.5x is the same, it's saying 2.5 times x. Okay. Now from here, what we want to do is get x by itself, because if we get x by itself, that tells us how many deer cover 25.5 square miles. So to get rid of this multiplication that's happening here, instead of multiplying x by 2.5, what's the opposite of multiplying to undo the math that's happening? Opposite of multiplication is what? Division. So I want to divide this side by 2.5. What do I also want to do to this side of my equation? The same thing, exactly. So remember, anything you do to one side of your equal sign, you have to do to the other. So we're going to divide both sides by 2.5. When we do that, these two 2.5s are just going to cancel because it's going to give us 1. And I'm left with x. And then let's type that into our calculator. So 178.5 divided by 2.5 tells me that I have 71.4 deer that cover 25.5 square miles. Now, I can't have 0.4 of a deer, right? That doesn't make sense. So I'm going to look at the whole number instead of the 0.4. So 71.4 is close to just 71 deers, right? So if I would have approximately 71 mule deers in the 25.5 square mile area. Okay. And then for part B is asking us, what does the point 7, 2.5 represent in terms of this situation? Well, 7 was the number of deers, right? If I look here at this proportion we set up, 7 was our number of deers, and 2.5 is the number of square miles. So if there are 7 mule deer living in the 2.5 square mile area, so B. So these two here. All right. Questions on how I got either of those answers, how I set things up, how I read the diagram that we were given? Jocelyn, are you good too? Okay. Next one. Number 4. Examine the following table, which shows the number of complaints a company received about its new windshield wipers since introducing them to customers. Which statement correctly describes the unit rate for this scenario? Let me over here and draw a table. So this is days in store. So I'm going to put a D for days in store and then C for complaints. Is it better? How about now? Okay. All right, so D represents the days in store that it was available, and C represents the number of complaints. So it looks like after 3 days in store, there were 9 complaints. After 6 days in store, there were 18 complaints. After 9 days in store, there were 27 complaints. So remember, for our unit rates, we have X and Y. That's weird. Give me here. Okay, so after 3 days, there are 9 complaints. 6 days, there's 18, and 9 days, there's 27. So remember, when you're writing your unit rate, you want to have Y over X. Okay, so we can pick any pair from our table and write Y over X. So if I were to choose the pair 3, 9, what would my Y over X be? 9 over 3, perfect. And if I want a unit rate, I need a 1 in the denominator. So to go from this 3 to 1, going to divide by 3, perfect. So I'm going to do the same exact thing up top and divide by 3. So 9 divided by 3 gives me what number? 3. So this tells me that after 3 days, I have, oh no, whoops, sorry. It's not days. It's after 3 complaints. I have 3 complaints after 1 day. Okay, so reading through these answer choices, which one, are any of these right? Oh yes, okay, I see it. There's just a typo in it. So again, how about now? Still robot? Okay. I don't know. I don't know. Okay. I guess we'll just hope that, we'll hope for the best. Okay, so when you read through these answer choices, which one correlates with what we have here? When we said our unit rate was they get 3 complaints after 1 day. see. Dawson says the second one. Natalie, do you agree or do you disagree? Agree. I agree as well. So this technically should say the unit rate is 3. The company receives 3 complaints every day. So I'm going to grab a sticky note and I'm going to write this down so I remember to put the typo in. So hopefully they change it. Let's see, this is number 4. All right, 5. For 5, remember, in order to have a unit rate, we need a 1 in the denominator. So when we have our y over x, we want to have a 1 in the denominator for our unit rate, which means that we're looking for where is x 1. And if I look at my table, x is 1 here, right? I have a 1 and 156, which means that this pair of numbers is my unit rate. So Dawson was correct on this one, the 1,156. Do you guys hear every time I mute and unmute? Do you hear the little person say that? Okay, that's just me. I'm just going to keep unmuting and muting because that seems to prevent the robot sound. So I'm just going to do that for myself. All right, questions on this one, or are we okay? All right, next one. Okay, so wind speed and water current on the Azul River are measured in the following table. And we want to know an equation. So which equation represents the proportional relationship between S, the wind speed, and C, the water current? Okay, so the first thing I'm going to do here is let's figure out what our unit rate is. Okay, remember when you have your diagonal table like this is your X and this is your Y. So if the first one I have is 9 and 1/4, remember I want Y over X. So 9 would go on top or bottom. If 9 is my X, do I want 9 to go on top or bottom here? On bottom. Perfect. So 9 is going to go on bottom, which means 1 4/5 is going to go up top. Now I'm going to take this fraction here and plug this into Desmos so that way I can figure out what my unit rate is. Okay, because my goal is to have this 1 4/5 over 9 to be a 1 in the bottom. So I need to divide this 1 4/5 by 9 to get my unit rate. So 1 space 4 over 5. And this whole thing divided by 9 gives me 0.2. But I want it as a fraction. So I'm going to hit this button to give me 1/5. So this tells me that my unit rate is 1 over 5, or 1/5. Okay, so now give me a second to look at these answer choices. So because my unit rate is 1/5, that tells me that I don't want to pick any of these answer choices that have the 5. Right? I want to pick either this top one or this bottom one. Let's see, so S is wind speed and C is the water current. All right, Dawson, you are correct. So the correct equation would be this C over S equals 1 over 5. So C over S equals 1 over 5. Alrighty, number 7. So we want to use the following table, and we want to know which statement correctly describes the unit rate for this scenario. Well, first, let's figure out what our unit rate is, right? If I'm looking for a unit rate, am I looking for my X or my Y to be 1? Remember, I have Y over X. I want to have a 1 in the bottom. So am I looking for X or am I looking for Y to be 1? So on this one here, the question's asking me to describe the unit rate, right? So this is like that other question where when I have Y over X, this is my unit rate, right? This is how I set it up. And for a unit rate, I need to have a 1 in the denominator. So do I want Y or do I want X to have a 1? Which one tells me that that's my unit rate, X or Y? X, right? So when you look at your table, is the first column or is the second column your X? Which column's the X, the first one or the second? Would it be, remember, when you have your table, it goes alphabetical order. So if you were just saying the alphabet, X comes first, Y comes second. So would pressure or would volume be our X column? Would pressure or volume? Pressure, yes. So since pressure is first, pressure is our X. And if I look through here, there is a 1. The very first one for pressure is a 1, which is what I'm looking for. I want to have a 1 in my denominator, right? So that means that for every 1 pressure, I get 0.3 milliliters in volume. So when I look through here, I'm looking for every 1 pressure, I get 0.35 milliliters of volume. So the volume of the can increase 0.35 milliliters for every 1 kPa of pressure. I know this one you guys seemed like you were a little confused on. Do we understand now seeing the answer, or do we have other questions? Okay, we're good. All right. The next one. A restaurant records the number of new guests who dine at the restaurant for lunch and what discount percentage was advertised that day. Okay. Is the number of new guests always proportional to the discount offered? Why or why not? Okay, so for this question, when you're figuring out if a table is proportional or not, what you're going to do is write your Y over X for every single one of your coordinate pairs and see if they reduce to the same number. So I have 5, 10, 15, and 20. And I have 8, 16, 24, and 32. So for my first pair, I have this 8 and 5. So when I write this as y over x, I'm going to have what number over what number? 8 over 5. Perfect. So I have 8 over 5. And then so the correctly answer both questions. So that's saying the first question is yes or no. So yes, it's either proportional or no, it's not. And then the second part, why or why not, is asking you to choose the right description. So I guess it is kind of weird because it says answer both questions, but there's not like a part A or part B. But it's pretty much just saying the yes or no and then the explanation. Okay, so then our next coordinate pair is this 10 and 16. So when I write this as y over x, I would have what over what? Eight over 5, yes, that's our first one. What about our second one with the 10 and 16? 16 over 10, perfect. And then our next one is going to be 24 over 15. And then the very last one is going to be 32 over 20. So to see if these are all proportional, let's type all of those into our calculator and see if we get the same number each time. So I have 8 over 5, 16 over 10, 24 over 15, and 32 over 20. So do all of these give us the same number? Yes, which means, is this table proportional? Yes, so since all of our numbers were the same, yes, this table is proportional, which means that this one that says no, we're not going to choose that one. So it looks like now we have to figure out which description is correct. So the very top one here says that the number of new guests is proportional to the discount offered. For every additional 5% discount offered, 8 more customers dine in at a restaurant. This bottom one says that the number of guests is proportional to the discount offered. For every additional 5% offered, 8 times as many new customers dine in at the restaurant. So it looks like we're looking at 8 more customers or 8 times as many customers dine in at the restaurant. If I look at the number of new guests, is to get from 8 to 16, am I doing 8 times 8 or 8 plus 8 to get to 16? Am I multiplying that there or am I just adding it? I'm going from 8 to 16. I'd be adding it, right? 8 plus 8 gets me 16. If I have 16 plus 8, I get 24. So we're looking at this one right here that says for every additional 5% discount offered, 8 new customers dine at the restaurant. 8 times 2 does work. However, that's not, I'm not multiplying by times 2 every time. So for this table, it's proportional because I'm adding 8 customers for every 5% that is increased. So make sure that when you're choosing this one, you're reading the reasoning very carefully. And then let me know when you guys are ready to go on to the next one. Natalie, are you good? It's okay, you're fine. All right, the next one. The table below shows the cost of a movie ticket based on the number of tickets purchased. Find the constant of proportionality, R, using the value for R, enter an equation that will calculate Y, the cost of X movie tickets in the form Y equals RX. So this looks very similar to our Y equals K times X formula, right? Except instead of K, we're using R. And wherever K is always what? What is K? The word I'm looking for starts with the U. What is K? Our unit rate, perfect. So K is always going to be our unit rate, which means that when I go to solve this equation with that Y equals Rx, all I need to do is figure out what my unit rate is and replace that number with R. So I have 2 tickets cost $17. So I want to know how much it is for 1 ticket. So I have 17 over 2. And I want to know how much it is for every 1 ticket. So I'm going to divide 2 by 2 and do the same thing up top. So 17 divided by 2 is what number? $17 divided by 2. 8.5, perfect. Which means that I pay $8.50 for every 1 ticket. So the equation that I'm going to type in here is Y equals 8.5 R. So anytime you are asked to write an equation, the number that is in your equation is always going to be the unit rate. Okay, so we're using unit rates for this whole unit, all of unit 2. So anytime it's like write an equation, always start with your unit rate and see if once you have your unit rate, you can kind of tell where to go from there. So Y equals 8.5 R. And let me know when you guys are ready to move on. So Y equals 8.5x. So that 8.5 is R because R is our unit rate. So Y equals 8.5x. There we go. All right. Next question says, examine the following diagram, which shows the proportional relationship between the number of sales made by a salesman and his earned bonus for those sales. So it looks like he made 1, 2, 3, 4, 5 sales and had a bonus of $299.95. And then he had 1, 2, 3, 4, 5, so 13 sales. He had 13 sales, which gave him $779.87. Still robot or better? Better now? Okay. So this question just wants to know what's the unit rate for this situation. So I'm going to use this smaller one because it has smaller numbers. Whenever you're writing a ratio with money, money always goes where? On top or bottom? Money always goes on top or bottom. Top, yes. So money always goes on top, which means for $299.95. Okay. Better? No? A little bit better? So our money goes on top, and if he gets a bonus of $299.95, how many total sales did he make? And yes, Natalie, I am. So how many sales did he make to get that bonus? Based off of the picture. How many pink dots are there? Five. Perfect. So for 5 sales. So to figure out what the unit rate for this situation is, all we need to do is just type this into our calculator. So $2.99 divided by 5. So the unit rate is $59.99 with that decimal. So 59.99. One off from $60. Yes, so close. All right, number 11, almost done. A landscaper is planting a public garden. She uses the following diagram to decide the number of ash trees to plant based on this garden size in acres. Okay, so when you look at this diagram here, how would you explain what this diagram represents to someone else? You look at this diagram, what would you say to someone else to explain what this diagram is telling you? So how many trees are represented on this diagram? 8, right? And how many acres are they being planted on? 1/8. So you could say something like 8 trees are being planted for every 1/8 of an acre. Okay, so part for blank 1, it says the landscaper will plant blank trees per acre of land. So am I looking for the unit rate there? What about that sentence tells me I'm trying to find my unit rate? The per, exactly. So per is telling me that I'm trying to find my unit rate. So if I plant 8 trees for every 1/8 of an acre, and I want to know how many trees I plant to get to 1 acre, I'm going to divide top and bottom by 1/8. So 8 divided by 1/8, which gives me 64. So I can plant for blank 1, 64 trees for every 1 acre. 64 trees for every 1 acre. All right, and then blank 2 says if the garden covers 7/8, 7/8 of an acre, she can use the equation blank to determine the number of trees to plant based on G, the size of the garden. Well, which one of these equations uses our unit rate? The first, second, third, or fourth one? The first one, right? So remember, anytime you're asked to find an equation or pick an equation, always choose the one that has your unit rates. So we want to pick that first one because it has our unit rate of that 64. All right. Next one. Are we good? All right. An engineer runs a test to locate errors in his software. The test scans each line of code in the software. The proportional relationship between the line scanned and the errors found is in the following table. Which statement describes how to solve for L? L here. Okay. Well, let's read through these because I think it might be easier to read through these first. The relationship between lines scanned and errors found. Okay. So the first thing we want to do here, actually, if you guys notice, it tells you what the value for L is, right? Sorry, my brain is moving faster than what I'm speaking. So at the very end of each sentence, it tells you the value for L, right? And if you notice, the value for L has different numbers, right? Two of them say that L is going to be 118, and two of them say that L is going to be 295. Yes? So what we're going to do is use this equation to figure out a unit rate. And then from our unit rate, we're going to figure out what L actually is. So I'm going to have 1 over 59, because remember, it's x and y. So I'm going to write y over x. And this is going to be equal to some number over 1. Let's divide top and bottom by 59. So 1 divided by 59, I can write that as 1 over 59. Okay. So 1 is our lines scanned. I'm going to put LS for lines scanned. And 59 is our error. So 1 over 59 is our error. And I have 1 lines scanned. When I look at L on this table, how many errors were found? So if L is here, I don't know how many lines were scanned, but I know that there were this many errors found. 5, perfect. So 5 is going to go up top for errors, and I don't know how many lines were scanned, so I'm going to put an X here, because I know there has to be something, but I don't know which. Now here's where we're going to do some cross multiplication. Okay, so let's multiply diagonal. 5 times 1 gives me 5. This is equal to, and then my other side is 1 over 59 times x. So this is 159 times x. All right, from here, all we have to do is get x by itself. So the opposite of multiplying by 159 is going to be dividing by 1 over 59. So we're going to divide both sides by 1 over 59. So let's type that in here. 5 divided by 1 over 59 gives me 295. So I'm going to erase this part up here. So this tells me that there were 295 lines scanned. So this is my L. Okay, so when I'm looking at these answer choices, I'm going to pick the one that says the unknown value L is 259. Now, there are 2 of them, right? This top one, this second one, and this third one both have the 295. However, if you look at the equations, this equation here says E is equal to 1 over 59L. And this top one says E equals 59L. Our unit rate for this problem was 1 over 59, which means that I want to pick this one for two reasons. One, because my unit rate is in my equation, and because the number of errors for L is 295. So yes, Dawson. So for you, it's the other one with the 295. Yes. And you can double check your equation in your description should have the 1 over 59. So you were very close. We just had the wrong unit rate. All right, guys, let me know when you're ready. We can do the next one. All right. A school plans a field trip for its students. They ask volunteers to chaperone the trip, and they record the number of volunteers and students that register for the trip over time in the following table below. Right. Is the number of chaperones always proportional to the number of students? Why or why not? Well, I can tell you this looks so weird. So when you're asked if a table is proportional, an easy way you can look at it is if I were to go from 30 to 2, I would divide by 15. 30 divided by 15 is 2. 45 divided by 15 is not 5. Sometimes you can kind of tell just the way with the numbers how they're looking. If you notice a pattern in your number from how you get from one side to another, then it is proportional. But you can also check by again writing those pairs. So 2 over 30, this should be equal to 5 over 45. And if we type these into a calculator, they will not give us the same number. Right, so see how these are different decimals, which means that they are not equal. And since they're not equal to each other, they are not proportional. So no, the number of chaperones is not proportional to the number of students. Questions on this one? Dustin, are you good? On to the last one. Examine the following diagram, which shows pixels per inch, PPI, for a digital screen for a certain size. Right. So how many inches of screen do I have if I have 28 PPI? How many inches of screen do I have? So when I look at the diagram here, 28 PPI tells me I have 5 inches of screen. Perfect. The first blank says, according to the diagram, a blank inch screen will have 48 or 44.8 PPI. So here is my 44.8 PPI. How many inches of screen will I have? So we just said that when I have 28 PPI, right, I had 5. So if I have 44.8, I would have how many inches of screen? So Dawson, out of your guess, which one do you think is more correct? Eight, exactly. So for blank 1, we're going to choose 8. And for blank 2, we want to know which proportion of PPI to screen size in inches compute blank. So this is just finding which one would we, or which setup would we use to figure out our unit rate. So Dawson says 8 over 44.8. So you're very close. When you're looking at diagrams like this, it's kind of the same thought process as with tables. So let me kind of redraw this. So here I have my box that has 1, 2, 3, 4, 5 dots, and then underneath I have my 28 PPI, right? So if this were to be a table, I would have X on top and Y on bottom. So it's alphabetical from top to bottom, which means when I write my Y over X, I'm actually going to have 28 over 5. So I would want to pick blank 2, which has the 28 over 5. All right, so that was the last question on the checkpoint. Are there any other questions, or are we okay? So on this question here, I just made the mistake. It should be the unit rate is 3 with the company complaints. 3 complaints every day. So that was my mistake.